All right, here we go. Let's consider this simple quadratic parent function, y equals x squared. All right, does it have an inverse function? You may be tempted to say, why, yes, Mr. Barwater, it looks like this. It looks like y equals square root of x, because square root and square, they undo themselves. Now, I got a problem with that. What does the graph of y equals square root of x look like? Well, hopefully you know that it looks something like this. Does that look like this that has been reflected? Now you say, oh, I know, Mr. Bauer, I know. We're gonna just go like this. We can go whoop, and we're gonna put a plus and minus in the front, and that solves all the problems. And you know what I'm gonna tell you? I'm gonna say, this is supposed to be an inverse function. Is this a function? And you're going to say, oh no, Mr. Bauer, that's not a function because it doesn't follow the vertical line test. I'm going to say you're right. Okay, so here's something that a lot of students have a hard time with understanding is the idea that an inverse function must be a function. So y equals x squared does not have an inverse function. All right, if we want it to have an inverse function, what we have to do is we have to limit it. We have to say y equals x squared when x is greater than or equal to 0. And really we should write it this way, right? So x is of the set of numbers where x is greater than or equal to 0. Or you could do the less than or equal to 0 is fine as well. But you can only limit it that way. Now, one way to tell right off the bat if a function has an inverse function is by using the horizontal rule. Because remember, when we reflect this about the xy, okay, which goes like this, right? Here's the xy, something like that. When you reflect it, all the x's and y's are going to switch, which means it's going to end up looking something like this. So anything that used to be vertical, anything that used to be y, is now x. It's now horizontal. Anything that used to be horizontal is now vertical. Now this is where the 1-to-1 comes in. Remember, I mentioned that in the last video. That has to be 1-to-1. Each x value can only have one y value. Now that's the definition of a function. But also each y value can only have one x value, because this y value right here, 4, has 2 different x values. Now that's okay for a function, but it's not okay to say we have an inverse function. And so we can test this by using the horizontal line rule or line test, and the horizontal line, since it crosses 2 points, means that y equals x squared does not have an inverse. Now, of course, to solve this, we just did that. So what we're going to do now is paste this graph, and so now we've adjusted it so that we have y equals x squared restricted to the domain of all the x's greater than 0. So, since we're at it, let's go ahead and do the inverse stuff and just kind of look at it. So if I want to do this geometrically, right, of course, we've got the inverse line that goes like this, which is not really part of the graph, but there we go. All right, that's fine enough. So I can take each of these points that are on this graph and just reflect them. Right? You can reflect them, or you can just kind of flip them. Now, the nice thing is, look at this point right here. That's 0, 0. What happens if I flip the x and y values? It's still 0, 0. Any point that's on this line will still be on this line for the inverse, because the x and y are the same. Same thing right here, right? The 1, 1. If I flip the x and y, it's the same. So any point on that line will still be on that line. Now, this one, which is 2, 4, will now become 4, 2, which is, as we talked before, very similar to the square root. In fact, it's exactly like the square root because that is the square root. And let's prove it. So we're going to take y equals x squared. That is the original function. And if we were to do the inverse, then we're going to switch the x and the y. So we're going to say x equals y squared. And to solve this, we're going to take the square root. And so the square root of x equals y. And so that is then your inverse function. Now we don't put the plus or minus because as soon as we put the plus or minus, it's no longer a function. And so therefore, it doesn't really fit what we're looking for. But there you go. That's talking about those ideas. Now let's look at one other thing really quick. And this is last video I talked about the domain and range. I said the domain of f inverse is the range of f of x, right? So that should make sense. If we look at this equation right here, for the x values, the domain is all real numbers greater than 0, right? The range, or how big this goes, is all real numbers greater than 0. I also said the opposite. The range of f of x is the domain of f. The range of f inverse is the domain of f of f, yeah. And so by the same idea, the domain here, or the range of the y values, is equal to the range of the f inverse values. And so the easiest way to find domain and range of an inverse function is to find the domain and range of the original function and just flip them. In fact, if you do that, you'll avoid many mistakes that students often make because they're throwing in extra pieces to the function, like the two sides of the quadratic that really shouldn't be there. Okay, so that's all I got for you today. I hope that that is helpful and that it will be clear as you start to do your homework. I will see you soon.